Hello there, it's Mr. Smith, and we're going to talk about part 2 of polynomials. You may be at the point where you're pulling your hair out because these polynomials are so complicated. How in the world am I supposed to figure out what a polynomial that's an x to the fourth looks like? Where do I know where the crosses the axis, what the end behavior is? Well, there are a couple of nice rays of sunlight that are coming through in this particular lesson, and those are the related ways to find zeros, which are called long division and synthetic division. We're going to take a look right now. Way back in the day, I'm sure in elementary school you learned about this little thing called long division. And in long division, you might have gotten this big worksheet from a teacher, and you might have had to figure out what 31 into 781 equals, or problems like that. I remember we had a big page of them, and it was so much fun. We even made up our own problems in the back of the room. Oh, that wasn't you? Well, maybe it was like this guy over here. I don't know. So let's do a quick little review of long division because it'll be helpful going forward. So right over here, I've figured out what happens when we divide 31 into 781. So watch with me here. So if you remember, the 31 is what's called our divisor, and the dividend is the 781. And the first step we would say is we would say, well, how many times does 31 go into 78? We took the first two digits here. All right, and we would say, okay, well, 31 times 1 is 31, 31 times 2, that's 62, okay, that's close. 31 times 3 is 93, that's too far. So we would put a little 2 at the top. It's part of our quotient. And then we would say, all right, well, what's left over? And we would say 31 times 2 is 62. All right, and then we would say, well, let's subtract that from our 78 to see what's left. All right, when we did that, we were left with 16. And then we would say, well, how many times does 31 go into 16? And we'd be like, crazy. So we would bring down the 1. All right, so we would have a 161 here. And then we'd have to think a little bit. 31 goes into 161 would be our next question, and we would work through it and blah, blah, blah. And we figured out 5 is the most number of times 31 fully goes into 161. And so we would do the same process. We'd put a 5 up here, and 5 times 31 is 155. All right, and we would do the same thing, so we're left with a 6. We don't have anything else to carry down. So what we would say is 6 is our remainder, and we would write little R6 up here. In other words, 25 and 6 divided by 31. Okay, so that was the long division process when we were dealing with numbers. Well, it's the same sort of process when we're dealing with dividing polynomials. So let's take a look here. Factor 6x cubed minus 41x squared plus 26x plus 24 using long division of 3x minus 4 as a factor. All right, so 3x minus 4 is our divisor. 6x cubed minus 41x squared plus 26x plus 24 is our dividend. Sorry. So we would say, how many times does 3x go into 6x cubed? Those kind of like the leading terms of each portion of our polynomial here. It's a little bit trickier, but we would say 3x goes into 6x cubed 2x squared times. Well, that's because 3x times 2x squared is 6x cubed. All right, so that's what goes up on the top, just like we did with the regular long division. On our next line, we would say, well, 2x squared times 3x is 6x cubed. 2x squared times negative 4 is a negative 8x squared. Now, the trick was, once we multiplied our divisor by that 2x squared portion, we subtracted, all right, just like we did with long division because we want to see what's left over. So we change all the signs of these so that it's subtraction. So what we're left with is a negative 33x squared, and then we carry down a plus 26x. We do it again. How many times does 3x go into negative 33x squared? Well, negative 11x times. Right, so we got an extra x and we got an extra negative 11 when we divide those two. All right, multiply again, negative 11x times 3x minus 4. So we end up with a negative 33x squared plus a 44x. And then we want to subtract. We want to change the signs. After that, 26x minus 44x is a negative 18x. Carry down that 24. 3x goes into negative 18x negative 6 times. It's the same process, -6 times 3x, -6 times -4, change the signs, and we end up with 0 when we subtract. All right, so what does this mean? What have we done? Well, what we figured out is this quotient actually factors out nicely, in fact. We figured out that 3x minus 4 is a factor because we get a remainder of 0. We also get this quotient here of 2x squared minus 11x minus 6. So technically, this cubic factors into 3x minus 4 times 2x squared minus 11x minus 6. And we can use our other quadratic factoring techniques to figure out that this factors to 2x plus 1 times x minus 6. Okay? Now, long division isn't always the best way to go about doing these things. It's not the quickest way, and there's lots of x's floating around, and that's not a good thing. So we've come up with this thing called synthetic division. And this is the same process, except it's going to like clear away all of the extra x's that we have to deal with. And unfortunately, it only works with linear factors of the form x minus c. All right. So for example, we've got 2x to the 5th plus x to the 4th minus 4x cubed plus x minus 9 divided by x plus 2. And if we can get the divisor in the form x minus c, we're going to be able to actually use this thing called synthetic division. Okay, so x minus c would imply that x plus 2 gives us a c of -2. The reason for that is x minus a -2 is x plus 2. So we know that c, is -2. And that's what's going to go in this little box right here. So you already noticed it looks very similar to what we did with the divisor, except all we're putting is the -2 in here. No x's involved. We're also going to make a line of all the coefficients of our dividend. So we've got 2, 1, -4, 0, because there's a 0x squared, a 1x, and a -9. So notice those correspond to all the coefficients in our polynomial. And it's a very repetitive process. So you're just going to do the same thing over and over again until you get to the end. So first thing is we're going to bring the 2 down. The 2 is our leading coefficient. And we're going to say -2 times 2 is -4. And that goes right below the 1 in this column right here. So we multiply what's in the box times what's below the line. And then we're going to add column-wise. So we would say 1 plus -4 is -3. And then we would multiply. -3 times -2, that's in the box, we get a positive 6. And then we would add. -4 plus 6 is 2. -2 times 2 is -4, right? So we're multiplying, then we're adding, then we're multiplying. -2 times -4 is 8. 1 plus 8 is 9. -2 times 9 is -18. And then we get -27. What does that mean? What have we done? Well, what we've done is we've created what's called a depressed polynomial. And the reason why we call it that is because what's remaining are the coefficients in our new polynomial that we get when we divide it. All right, and it's depressed because we're dividing by an x to the first power, so everything goes down by a power. So therefore we could say 2x to the 5th plus x to the 4th minus 4x cubed plus x minus 9 divided by x plus 2 is a 2x to the 4th, this first coefficient here, minus a 3x cubed, notice how all the powers are going down by 1, plus 2x squared minus 4x plus 9, and then minus 27 over our divisor, which is the x plus 2. That's our remainder part. All right, so one last thing. Wonder if we have something like a 2x minus 1 in our divisor. What do we do? Well, in order to get the form x minus c, we're going to divide both our numerator and our denominator by 2. So that's going to give us our divisor of x minus 1/2 and a c of 1/2. And then I'm going to divide all the coefficients of our dividend by 2 as well. So we're going to get a 3/2, a minus 1/2, an 8 divided by 2, which is 4, 4 divided by 2, which is 2, and -1 divided by 2, which is -1/2. And the process goes the same. Beware, there's going to be fractions. So 3/2 gets carried down. 3/2 times 1/2 is 3/4. 3/4 minus a half is 1/4. You'll trust me on that. 1/4 times 1/2 is 1/8. Then we got to think a little bit. We'll do 4 plus 1/8, which is 33 over 8. 33 over 8 times 1/2 is 33 over 16. And then 2 plus 33 over 16, 65 over 16 times a half, which is 65 over 32. And finally, we end up with 49 over 32. So what have we done? When we divide the quartic by 2x minus 1, we end up with 3 halves, x cubed, plus 1/4 x squared, plus 33 over 8x, plus 65 over 16, plus 49 over 32, that's our remainder, divided by x minus a half. So in summary, long division and synthetic division, they're both great ways to figure out whether or not a value is a zero of a polynomial.